Welcome to the Explainer. Today, we're going to tackle a really big shift in AI that's happening as we speak. How do we secure AI agents that can, write and run their own code? So let's jump right in with the core idea here. It turns out that the most efficient way for an AI to solve a problem, well, it isn't just to talk about it. It's to actually write and execute its own code to get the job done. And look, we're not just talking about heavy-duty software development stuff. We're seeing models that, if you give them the chance, will just spontaneously use code for simple things, like cropping an image or pulling text from a file, just because it's way faster and more reliable. And honestly, this is a massive shift. You see, the old way of building these AI agents, it was kind of clunky, right? You had these complex chains of different models, each one just handling one tiny part of a task. But the new way, it's so much more elegant and powerful. You've got a single, super advanced reasoning model that just looks at a problem and decides for itself, you know what, I'm going to write some code for this. And then it just does it. Okay, but with this incredible new capability, we're suddenly face-to-face with a classic security problem. I mean, this is something developers have been wrestling with for decades.
Right. In the security world, this is known as remote code execution, or RCE. And let me tell you, it's considered a critical, like 5-alarm fire level of vulnerability. And here's the crazy part. We are, for all intents and purposes, intentionally giving these AI agents RCE capabilities. So the question really isn't, can the models do this stuff anymore? The question is, what should we allow them to do? And what kind of guardrails do we absolutely need to put in place?
So that leads to the really critical question, right? When you hand an AI this kind of power, what can actually go wrong? What are the real risks we need to be thinking about? Well, the risks really run the gamut, from the straight-up malicious to just plain clumsy. I mean, top of the list, you have stuff like prompt injection, where a bad actor tricks the AI into leaking sensitive data. But then you also have the simpler, unintentional oopsies. The agent could just make a mistake and delete the wrong files. Poof. Or it could accidentally install some malicious package from the internet. It could even write brand new code that has its own security holes. So, this brings us to the crucial point. How do we build the right guardrails so we can get all the amazing benefits of these agents, but also protect ourselves from all those risks we just talked about? Well, the good news is researchers are already laying out a really clear framework for this. And based on OpenAI's own experience building and deploying these agents, it really boils down to 3 essential safeguards. These are like the bedrock of responsible AI agent security. So let's break them down. All right, first up, and this is probably the most fundamental one, you have to sandbox the agent. Now, a sandbox is pretty much what it sounds like. It's a controlled, totally isolated environment where the AI can run its code without being able to mess with the rest of your system. Think of it like giving it its own little padded room to play in, where it can't break anything important. And there are basically 2 main ways to go about this. For maximum, top-level security, think about how ChatGPT does it. The AI runs its code in a completely separate, disposable container. It does its thing, and then that container is just destroyed. Poof, gone. But for developers, just working on their own laptops, you can use built-in features in your operating system to create a more lightweight, local sandbox. It's still going to give you that critical layer of protection. Okay, safeguard number 2. This one tackles what a lot of experts think is the single biggest risk: uncontrolled internet access. I mean, think about it. If an AI can just browse anywhere on the web, it can be tricked by malicious stuff hidden pretty much anywhere.
Here's a perfect example. Let's say you ask the AI to go fix a bug, and the description is on a public GitHub page. Well, buried deep in the comments, someone could have hidden a malicious little prompt. The AI, just trying to be helpful and follow all the instructions, might read that, grab your latest private code, and then just send it straight to an attacker's server. And yeah, this isn't science fiction. This is a very real risk.
And that brings us to the 3rd safeguard. And this one's a big one. Even with the best tech in the world, one of the absolute strongest protections we have is simply keeping a human in the loop. Technology can fail, things can be missed, but a pair of human eyes, a thoughtful human review, that can catch what a system might not. But of course, there's a balance to be struck here.
On the one hand, you have to avoid what some people call YOLO mode, where the AI just runs wild completely unchecked. But on the other hand, you can't have a person sitting there approving every single little command. That's just not practical, and it leads to what we call approval fatigue, where you just start clicking yes, yes, yes without even reading. So the key really is finding that sweet spot. You monitor the agent's actions, and then you require explicit human sign-off for the really sensitive stuff, like installing a new program or committing the final code changes.
So let's put this all together and see how it fits into a practical framework for anyone out there who's actually building with these amazing tools. What's so useful here is how this lays out your choices, because it's not all or nothing. It's a spectrum. For each one of these safeguards, sandboxing, internet, human review, you can dial it up or down. You can go for maximum security, a remote sandbox, zero internet, and approving every single action. Or you can aim for more flexibility, a local sandbox, a pre-approved list of websites it can visit, and just monitoring for the really sensitive actions. The right choice? It totally depends on what you're building.
And this, right here, really gets to the heart of it all. This isn't about holding back progress or, nerfing the AI. It's actually the exact opposite. It's about creating a solid framework so that we can confidently and safely unleash the incredible power of these code-executing agents, all while making absolutely sure that a human is always, ultimately, the one in control.
And so that leaves us with this really fundamental question, one that we're all going to have to answer as these tools get woven deeper into our lives. We are literally building agents designed to be autonomous, but how do we make sure that the final say, the final decision always rests with the human? That's the real challenge, and I think the real opportunity of this whole new frontier.